Alright, got this 2004 GMC Sierra 2500 HD 6.6 liter Duramax. We got 269,324 on the odometer. And the concern, or concerns, is no turn signals and no crank. So you can see we ain't got nada. So let me show you what I found.
So it's important to keep in mind that this vehicle came in, the shop that it came from started this vehicle, all right, and was able to drive it to the shop, okay? And the way they did that was they just jumped pin 30 to pin 87 on the starter relay. So what I'm going to do is I'm going to pull up the starting circuit for this vehicle so that as I'm explaining the testing process I went through, you can get a visual of what I'm talking about. All right. So I've got service information up right now for you. So let's go into the manual. So let's go into engine, and we want to go to engine electrical. Okay. And then we want to go to schematics and routing diagrams. And here you can see starting and charging system, except HP2 and HP2. Okay. We had one that did not have HP2. Starting diesel is what we want. And let me just pull this up for you guys so you can see it better. All right, so here's our starting circuit for this. And what the customer was doing was taking pin 30, which is right here, and they were jumping it to pin 87, okay, which is right here, okay? So we got pin 30 up here, pin 87, and it's not labeled on the diagram. And then we've got pin 86 here on the control side and pin 85, all right? That's our starter relay. Anyways, what this test is going to do, if I remove this starter relay, which is what I did when I came out to the vehicle after I did my health report, which no DTCs, right? I took the relay out, put a relay bypass switch in, which is just a test. I have a kit from Matco that allows me to be able to basically to do the exact same thing. So I popped that in there, switch it, got the ignition in the run start position, and I was able to crank and start the engine, okay? This tells me quite a bit, all right? This is going to tell me that my ignition A fuse, this 40 amp fuse right there in the underhood fuse box, is good, okay? It also tells me that circuit 6, the purple wire here going down to our starter solenoid, that wiring is all good, as well as everything internal to the box related to that load side of that relay. The starter solenoid obviously is good because it engages and it does what it needs to do. The ground for it is good, right on the block, part of the starter. The motor, the starter motor itself is good, okay? So I'm not worried about anything to do with the starter, anything to do with the solenoid, anything to do with the load side of that relay or that starting relay, or starting circuit. Now, get it into the to the bay, and the next thing I want to do is I want to install a relay adapter, okay, a relay testing adapter. You can certainly do this with the relay in the box. You just would have to put it in just enough where you can get access to each leg, each pin. I'll show you here on the wiring diagram, but so I'm able to touch like a test light to any one of these pins on the relay itself. But my relay testing adapter is going to give me the ability to do that with it elevated and make it a lot easier for me. So on here, I just went ahead and I labeled all the pins for you guys just to cut down on confusion, okay, on this wiring schematic. And what we're doing with this test is we're taking a 160 milliamp test light hooked to battery positive, and we're looking to see if we're able to light that test light when we have someone jump in and put it in the crank position. And we're on pin 85 here, okay, and you can see that circuit 625 going down to the starter enable control coming from the ECM there. That's what we're testing. We're testing to see if the ECM is switching the ground side on the control here, because if you look at pin 86 is a feed that comes from our park neutral position switch up from ignition E fuse 10 amp, the 10 amp fuse, and that's going to be hot in start or run, okay, or crank, okay. And what I want to see here on pin 85 is I want to see my test light, and that would tell me that the computer is in fact switching the ground to it, and we have control from the ECM when we crank it. That's going to rule out a lot of things with that one single test. What that's going to rule out is the ECM. It's going to rule out circuit, this yellow black wire, circuit 625, going down, coming from the ECM up to the relay and the fuse box. It's going to rule out all of that, okay? And that's going to tell us that we have control. It's there. Now we're headed towards, this ignition E fused circuit, okay? So when I did that, I was able to light the test light. So that confirmed that the underhead fuse box, internal circuits, as well as circuit 625 yellow black, starter relay enable control coming from the ECM up to underhood fuse box were all good. So that rules all of this out. The next test that I did, again, with the ignition switch still in the run start position, with that relay tester adapter still installed, is I wanted to check the control side of the starter relay using the same 160 milliamp test light. Only difference is I'm going to change my polarity, and I'm going to go over to battery negative now with my test light. And what I'm going to be looking for is a 12 volt, a lit test light on pin 86. Okay. And if I have a lit test light there, that's going to tell me that my ignition E fuse 10 amp coming from this fuse block, coming from the fuse box, right? And there's obviously you can see here, if you look, there's a pink wire, circuit 639, coming from that ignition E fuse down to our park neutral position switch, which is going to be in the closed position in what? Park or neutral. And it's going to come out on this dark green wire, circuit 1433, and come up to our pin 86, come up to our underhood fuse box, which internally is going to go to pin 86 on the starter relay, okay? So I should have a power feed there, as long as my ignition switch is in the run or start position, or in the crank position, to be honest. Now, when I did that test, as you'll see in the video of me doing that test, is I was able to get a lit test light, but only when I would apply pressure to the ignition E fuse. But on the side of the ignition E fuse that goes to, if you look up here on the diagram, you can see the ignition E fuse 10 amp. It tells you to go to power distribution wiring schematics to see what else is on that side of that fuse, okay? And we got to find out where that power feed for that side of the fuse is coming from, because again, without pressure on it, I was unable to get a lit test light, which is the reason for the no crank condition.
So here's our starter relay. I've already got it pinned out, or I've already got a test relay tester installed underneath it. Hooked to battery positive right now. Okay. And we're going to go to pin 86 here on the relay, which is our switched power feed coming from the run crank bus bar internal to the fuse box here, which powers up our ignition E fuse, which is this 10 amp fuse here. So right now with the ignition on, or in run crank, if you will, let's go ahead and switch our polarity over to battery negative and see if we got power on this fuse. Alright, I don't know if you guys can see what I'm doing there. There you can see I've got no power on either side of that fuse. Oh, there we go. So as you can see, if I put pressure on it, right there, I've got power, okay? If I come to my relay and I touch pin 86, which is the control side of that relay, I got nada, okay? So what I've got going on here is I'm hooked to battery negative. You can see I got no test light on pin 86 right now with the ignition on. Just gonna gently press on that ignition E fuse, and you can see got a good light when I put pressure on it. So
okay, so we've narrowed our issue down to that ignition E fuse in the underhood fuse box. I want to see where it gets its power from. I want to see what it all powers up. Okay, that's what I want to do next. And what I'm going to need for that is a power distribution schematic. Okay, we're using factory information here, so sometimes it can be difficult to find that power distribution schematic, especially on the older ones. But I'm going to show you where to go and where it's at. So if we go under body here and we go to wiring systems down at the bottom here, schematics and routing diagrams, you're going to see power distribution schematics. Okay. Now, these are all our power distribution schematics for this vehicle. Figure 18 here is our ignition E fuse, which is the one we're concerned about. So let's click on it. We'll expand it here so you can see it. Okay, so if you look up here, here's our ignition E fuse, our 10 amp fuse that we're concerned about. We were applying pressure on this side of the fuse, and we were able to get our test light to light, hooked to battery ground, right? So our issue is in between the ignition E fuse, the 10 amp fuse here, and the run start bus bar, okay? That's where our problem is, internal to this underhood fuse box. However, that ignition E fuse, that 10 amp fuse, also powers up the, if you look here, the AC compressor relay on the control side. That's also the power feed for the control side of the AC compressor relay. In addition to going down circuit 639 here on this pink wire, down to our park neutral position switch, which we know, looking at the starting circuit, is the switch that's obviously going to be closed when it's in the park position or the neutral position and provide that power feed to the starter relay control feed, okay? And if we look at where it breaks off internal to the underhood fuse box up here, you can see that it also comes over this one here on circuit 639 comes down, again, we're dealing with domestic, and it powers up our turn signal multifunction switch. So no turn signals was another concern. Well, look what it's powering up, the turn signal multifunction switch. So we're going to fix AC compressor issues and turn signal issues. Now, again, they weren't complaining about the AC compressor not kicking on. Maybe they don't care. Maybe the AC is not charged. Doesn't matter. We're going to fix 3 problems by putting a new fuse box in this. Now, some might argue, well, Pauly, why didn't you just fix that terminal in the box? Well, really? Is it worth my time for a $350 fuse box? No. Well, why don't you just wire an external fuse? Well, we could, but I'm going to need that hot and run start feed from that bus bar, and that's internal to the box. So is it worth it? Is it worth it? That's my point. It's not worth it. These things were a wiring nightmare. If anyone's ever pulled a fuse box up on one of these older Duramaxes, they weren't, the wiring wasn't put together all that great to begin with. So I don't really want to, on top of all the aftermarket crap they got wired into this box, which, I mean, you can take a look here. I can throw some pictures up for you. I mean, look at, they had these resistors, for the lighting relays, because they have LED lighting in there, all plugged in and pressed down in there. So was this created by something? Was this pin fitment issue or internal problem created by somebody stuffing something down in there they shouldn't have been? Who knows? Okay. Who really knows? And who really cares at this point? But I'm not going to add to the mess. Okay. I'm just putting a fuse box in it, and that's exactly what I did. And it fixed it. Okay. Fixed everything. What I want you guys to pay attention to is on this particular part of this is, okay, so let's take a look at this turn signal multifunction switch schematic, because this is only a partial view of it, and just kind of look at it, all right? So let me go up here and go back, and we're going to go back Okay, again, we're in body, and we're going to go to lighting systems, schematics, and routing diagrams, okay? And we're going to go to exterior light schematics. And right here on figure 12, you can see turn signal multifunction. That's the one we want. And if we look at this one, again, sometimes GM's program doesn't do the greatest here on actually expanding them when they're supposed to. I don't know if it's a refreshing issue or what, but anyways, here you can see the ignition E fuse 10 amp, that the one we're concerned about. Comes down on circuit 639. Again, we're dealing with domestic. Comes down, continues down, and it comes into our turn signal multifunction switch as drawn, right? That powers up the switch. Depending on which way you have the switch, it's going to power up 1428 or 1427, depending on if you want left or right signal. And that's going to provide power to our hazard, our turn signal hazard flasher module down here, which is internal to our fuse blocks in our instrument panel, okay? Again, this is only a partial view because you can see the dotted lines, but you can see the fuses down here. Left turn signal fuse, 10 amp. Right turn signal fuse, 10 amp. And then, of course, you have your trailer fuses. So just by us fixing this, replacing this fuse box, we're going to fix multiple issues. All right.
To prove this out, what I want to show you guys is, and I press on that fuse. Let's see here. Okay, so I put enough pressure on it where I was able to keep the power going to pin 86 on the starter relay. So now this thing should crank up. The other thing I'm going to explain to you, I don't know, again, I'll do this in the edits, is now our turn signals are going to work, as you can see. Okay. Because that starter relay and the multifunction switch for the turn signals all share that ignition E fused feed. So now, if I go ahead and crank it, it's going to start. And there it is.
What else was I going to explain to you guys? Oh, factory information can be wrong. Because when I was doing my initial look at the starting circuit, let me go back to that starting circuit wiring diagram. So what I want to explain to you is how factory information can even be wrong, okay? And the reason I noticed this was because when I was initially looking at this, I obviously wanted to kind of look at all the possible areas I was going to have to go, okay? So when I was looking at this starter relay on pin 85, which would be our control switched ground for the starter enable relay control from our ECM here on this yellow black circuit 625, you can see down here they've got two different options. It depends on if you have an LLY engine or you have an LB7. Well, we're dealing with an LB7, okay? And they're saying that's on the ECM C2 connector, okay, on pin 4. Now we go here, connector ID, C for the LLY, or we're dealing with the LB7, so connector ID C2 is the clear connector, okay? It's the clear connector. There's a blue and there's a clear. So they're identifying it for us here. This is correct. This is correct, drawn as it's drawn, okay? But when I pull my pin out of the C2 for the LB7 ECM connector, I want to show you that pin 4 is mislabeled, okay? So let's go back out. We're just going to go here. Let's see, back. And if we come up here, it says master electrical component list. We're going to click that. And we're going to go to engine module. Engine control module, ECM, LLY. Okay, well that isn't what we want. So let's try engine control. Okay, so yeah, so look at here. You can see here it says engine control module ECM LLY. Tells you where it's at. But then they have over here locator view. Okay, so if I want to see where it's located, you know, find it, give me a figure of that. But you can see they have the LB7 and the LLY connector end view hyperlinks here. So let's go to our LB7. All right, so here's our C1 connector. This is the blue connector, okay? That's not the one we want. We want the C2. And let's go down to C2's connector end view. So here's C2, clear. And if we go to pin 4, 3 through 5, not used. So it's misdrawn, okay? Or, well, it's not drawn. There is no starter relay enable control circuit shown on the pinout here. But however, if we look at the starting wiring schematic, it says it's on pin 4. Now, you go down to that connector, I'd imagine it's going to be on pin 4. But it's just something to keep in mind that factory information can even be wrong from time to time. And all your aftermarket platforms, Protoman, ALLDATA, whatever, okay, they're drawing their schematics or pulling their information from factory information. Well, this 04 schematic or pinout for C2 connector on the ECM is wrong. Okay, it's not even showing the yellow black for that starter enable relay control circuit there. So it's interesting. I just happened to notice that when I was poking around because I was like, oh well, I'm just gonna write down my document ID numbers for all these different pinouts in case, and this is before I even start testing, in case I need to go there, I don't got to go back to the computer, get the information. I got it there. I'm ready to rock, right? Anyway, something interesting to think about. In either case, I hope you guys find this helpful. I mean, I know it's nothing crazy. I know I have very minimal on-car footage, but at least I walked you through on how to test it and what to do to test it. Nothing too spectacular, nothing too crazy. Could be easily missed because, as you've seen, I was able to put enough pressure on that fuse and fix the fuse box temporarily. And you might be like, oh, well, it's just, it's fixed now. And what happens if it is one of those things where it's not a clean, clear-cut issue with that connection at that fuse, and you put a little pressure on it and the problem goes away, and it's not going to present itself for another 2 to 3, 4, 5 weeks, and you send the vehicle down the road because you couldn't find the problem, and it's still there. So something to think about, something to consider. In either case, I hope you guys liked it. Catch you on the next one. God bless.